Hello, I'm Papia. In this problem, we have the function fx equals 2x minus 3. We have to first figure out the inverse of this function. Then we have to graph the function and its inverse in the same xy coordinate plane. Third part of this problem is to describe the relationship between f and f inverse. And then finally, we have to determine the domain and range of both functions. Okay, so let's start with describing what the inverse of f is. And we denote it as f to the power negative 1. That's the inverse. So how do we find f inverse? You take your expression for the function f, write it down as y equals 2x minus 3. So that's where you start. Then we're going to solve for x. Okay, so let's solve for x. How do we do that? So we bring this negative 3 on the left side as positive 3. So it's y plus 3. That's equal to 2x. And then we make x free of any other constant. So we divide both sides by 2. So we get y plus 3 divided by 2 is equal to x. So when you solve for x, the next step is you just interchange x and y, the variables, and you will get your inverse function. So interchange x and y. So we will have x plus 3 over 2 is equal to y. Guess what the f inverse is? Is this expression right here. So f inverse, or the inverse function of the function f, is x plus 3 divided by 2. All right, so notice that the function f and f inverse, they're both straight lines. Okay, you can already see that from the expression itself. So when we have to graph them, you can just find 2 points on each function on the curve, and then you can draw the lines, right? So let's do that. Take f, and let's figure out 2 points, so x and y. Just make a small table. Okay, you can plug in x equals 0. This is the function f, okay, the original one. So if you plug in x equals 0, we get 0 minus 3, so you get negative 3. And then let's plug in, say, x equals 2. You can choose any points. I'm just randomly choosing 2 points. So if we plug in x equals 2, what is y value? 2 times 2 is 4. 4 minus 3, that's 1. So those 2 points will give us exactly what this line will look like. Okay, so let's plot that right away. So our points are 0, negative 3, and 2, 1. So 2, 1, right here. So this is function f. Let's do the same thing for f inverse. Make a small table, plug in some x values and some y values. Now f inverse, the expression is right here. So I want to choose x equals negative 3. That's my first value. Why did I choose that? If you just notice, if we plug in x equals negative 3, you get negative 3 plus 3, so it's 0 over 2. So I get y equals 0. Again, you don't have to, but it's up to you what you want to choose. And let's plug in, say, x equals negative 1. So if I plug in negative 1 plus 3, so that's 3 minus 1, that's 2 over 2, y is 1. Again, you can choose any 2 points. All right, let's plot them now. So we have a negative 3, 0, and negative 1, positive 1. So F inverse is that line. Okay, so we have graphed both F and F inverse on the same coordinate plane. Now, let's move on to part C. What is the relationship between a function and its inverse? Can you tell? Do you see that they are kind of like mirror images of each other? But where is the mirror? Okay, so guess what? The mirror is y equals x. So let's check that. See, if you graph y equals x, you can see if this is the mirror, if you place a mirror right on y equals x, f and f inverse, they are just images of each other. So what it means is, what is the relationship between them? It's that f and f inverse are symmetric about y equals x. So that's the relationship. F and f inverse are symmetric about the line y equals x. And that's what happens for any function and its inverse. Okay, they're always mirror images about y equals x. All right, finally, we have to figure out the domain and range of both these functions. Now, notice that, let's consider f first. It's just a line, right? So, are there any x values that you cannot plug in this function without causing any problem, I mean? Well, think about it. There is no denominator, there is no radical. It's just a polynomial, just a line. So you can plug in any x values and you will always get an output. So the domain is the entire real line. So for f, domain is everything between negative infinity and positive infinity. Finally, what is the range? Well, look at this graph. It'll keep on going both directions, which means all these y values you will get as an output for some x as input, right? So the range is again the entire real line because it's just a line. So the range is also negative infinity to positive infinity. What happens for f inverse? Same story, right? F inverse is also a line. Same thing will happen. But there's another fact about finding domain and range. What happens is, when it's the inverse of f, the domain of f inverse is actually the range of f. So you can even consider it that way. So the domain is range of f, and that is all real numbers. And guess what the range of f inverse is? It's the domain of f. So this is the domain. And that is also everything between negative infinity and positive infinity. So we completed our problem. Thank you.